Good morning, my name is Peter Shields and on behalf of EMET Scientific I'm pleased to welcome you all to today's webinar, Video Exposure Monitoring in Occupational Hygiene. With such rapid advancements in technologies these days, it's great to have Debbie Dietrich from SKC back with us to present on this exciting field that combines the use of video and real-time sensors to help occupational hygienists visualise exposures as a function of work tasks, an excellent tool for educating workers in safe work practices. I'm sure you'll find the presentation extremely interesting. I'll now hand over to Debbie Dietrich, Vice President and COAH at SKC. Over to you now, Debbie.
Well, hello, Australia. This is Dusty Debbie back with you. I am pleased to welcome you to this training event. I'm always happy to reconnect with my friends down under with my terrible Australian accent. So thank you very much again to EMET Scientific for arranging this webinar. Now, I've been in this profession now for more than 30 years, and I honestly can say that I still find occupational hygiene to be so interesting, so challenging, and honestly fun. There is always something new to learn and share. The science of occupational hygiene, as well as the technologies, continue to expand so we can address new industries, new hazards, and develop new ways to protect those at risk. In this webinar, we are going to take a new look at an exposure assessment tool called Video Exposure Monitoring, or VEM. US NIOSH actually began using an early form of this technology way back in the 1980s. And in 1992, NIOSH released an excellent publication on this technology. It is still available today. And you can do an internet search for the document by simply searching with the publication NIOSH 92-104. Alternatively, at the end of the webinar, I will be sending EMET a copy of this webinar as a PowerPoint, so you can access any of these links that I have in the presentation. Now, NIOSH has now reawakened the interest in VEM with the release of EVADE in 2014. EVADE, if you haven't heard of it, is a free software program available online, free, that allows users to merge video files and logged data files from direct reading instruments. And despite the name, Enhanced Video Analysis of Dust Exposures, EVADE can be used for more than just dust. It has been used for noise monitoring and more. So this is indeed an exciting time for VEM. You know, in addition to NIOSH's new software, developments and advancements just generally in video technology, sensors, and computer technologies have enhanced the interest, value, and application of VEM today. Now, of course, my personal interest is in air sampling, and I think that this slide really captures the essence of VEM for this application. And this is directly from the NIOSH publication. They make the point that integrated air sampling using collection media allows us to determine the extent of chemical exposures. But air sampling alone does not allow us to determine the causes of worker exposure. VEM can fill that gap. By combining videography with data from real-time sensors, hygienists can actually visualize exposures as a function of the work task. And armed with that information, hygienists can better target, tasks that are actually generating the higher exposures. They can pinpoint the source and path of emissions and leaks. They can identify and quantify peak exposures, develop effective controls to mitigate exposures, and then, of course, evaluate the effectiveness of those controls. So a lot of good outcomes from the VEM technology. Now, some additional benefits from VEM are shown on this slide. First, a human factors issue. Professionals can evaluate work flow along with work practices. Training and communication is enhanced when workers and management alike can sit down and actually visualize exposures when job tasks are first uncontrolled and then controlled. And finally, there are some just business-related benefits for the employer. VEM, of course, can help to reduce accidents and illnesses and thereby lowers workers' compensation insurance issues. Job productivity can be increased by choosing a control technique that workers will accept and actually use. Now, I decided to do this webinar on VEM today because I have been studying this subject, honestly, intensely through one of the VEM pioneers and inventors, Dr. James McLaughlin. Jim was on the original team at NIOSH that developed the VEM concept in the 1980s, and he continued his research during his tenure as a faculty at Purdue University. He has developed and patented some VEM software with some unique advantages, and he hopes to bring those to the commercial market. Now, Dr. McLaughlin has traveled all over the world doing studies using VEM in many different work environments. And if you go to YouTube and just even search under video exposure monitoring, you will see one of his YouTubes. And I will, of course, provide the link to this on the PowerPoint as well. But anyways, as I was going through his YouTube, he has a lot of different video clips. Believe it or not, there's actually a video clip of his work using VEM in Queensland. He used a VEM in an IAQ study at the Ecosciences building in Brisbane. And he used VEM to help identify and control these IAQ issues. Okay, so now I explain the basics so you can understand how it all works. The output from a real-time monitor is synchronized with video to see changes in exposure as a function of the job. Just for example, let's look at a particulate monitor. With VEM, you can watch a video of workers conducting their job task and at the same time see the resultant dust levels from those tasks on the computer screen. VEM can be used with a variety of environmental instruments, not just particulate monitors, noise dosimeters, radiation monitors, PIDs. They can be used with other devices like heart rate monitors if you're trying to look at the health effects of an ergonomic issue or a chemical. A little later, I will show you some actual videos to demonstrate the technology, right? This is a webinar on video exposure monitoring, so I got to show you some videos. Now keep in mind, however, with transmitting this from one continent to the other using the webinar software, we did a little test run. The video will appear choppy tonight, but I will just for now just capture what I hope it's good enough for you to capture what I'm trying to illustrate. And later, you'll get the PowerPoint with embedded video files or links to YouTube for a better view. Now on this slide, here's the first video. You can see how VEM was used to compare dust exposures when cutting concrete under various conditions and controls. Now this is actually 3 separate videos that we just put on one slide. You can't get like 3 in one on the one VEM. Okay, and on the left you can see the job being done dry. The center video shows the job being done wet as a control measure. And the right video shows the job using local exhaust ventilation. And of course on the bottom you can see the dust exposures logged by the instrument as the worker does the task. Now shown here are the critical components of a VEM system. First, the sensor technology, some sort of direct reading monitor. Next, the video technology, the camera, which can be mounted on the worker or placed in an area. Finally, the computer technology, including the option of streaming wireless data transmission from some of the commercial software. And then a computer, of course, for playback. So now we'll take a look at each of these components. First, let's focus on the video equipment itself. Even in the 1992 NIOSH publication, which is a long time ago in technology years, right? The use of 2 types of video equipment was discussed. First is your conventional video equipment to just document worker activities. The second option is really, really cool. Infrared video equipment. IR cameras will allow you to actually visualize gaseous air contaminant plumes. And as you will see later in the video clip, the infrared video equipment can provide a real-time picture of otherwise invisible emissions of gases and vapors. So you can see the source and path of any leaks and emissions. This technology is also useful to see the effectiveness of controls that have been implemented, such as scavenging systems in medical facilities for anesthetic waste gases. Now on this slide you can see this extremely small infrared cameras that are available today. And these are priced in the US at less than $500. Our very young, tech-savvy electrical engineer at SKC purchased the tiny IR camera shown on the right side that is clipped to a cell phone to visualize the images. I mean, it is really amazing. I think that camera was like $250. There is one disadvantage, that was noted in the NIOSH 1992 publication. Basically, NIOSH makes the point that the IR technology is useful for leak detection, but the sensitivity does not allow for visualization of the gaseous emissions in the range of occupational exposure limits. You know, for example, you're not going to see 1 ppm benzene. You know, when I first began studying this whole concept of VEM, one of the first questions I asked is whether intrinsically safe cameras were available commercially. You know, in a quick internet search, sure, there's a lot of cameras, you know, at a price. But keep in mind that many of the direct reading instruments themselves are not intrinsically safe. Most dust monitors, for example, are not intrinsically safe. So the cost of the intrinsically safe cameras may not be worth it. Another common question is whether VEM will work with cameras like GoPro. The GoPro in particular, I've been told, has a built-in program, unfortunately, so they cannot cross-talk to other software programs. And that's put in there, for proprietary reasons. So not all cameras out of the box will work with VM for these proprietary reasons. Now, what about your video camera on your phone, right? I mean, think about it. Can you remember the days that parents in particular carried around those big clunky camcorders on their shoulders? It seems like unbelievable. Do people still do that? Now cell phones do the job and allow for easy file sharing. So the very clever SKC electrical engineer decided, hey, I'll try out this option for VEM. What he did, he put these headset thing or face, something on his face, and taped his cell phone to his head. Clever guy. Then he recorded his soldering activities while being monitored with the SKC HAZDAS monitor. And after this, he downloaded the video files and the particulate files and then manually synced them and viewed the output using the NIOSH Evade software, which worked really well. But of course, no one wants a phone or a camera taped to their head. Thus, we have devices such as the helmet cam that was created by NIOSH in 2013. At that time, the helmet cam was considered a wow, what a great invention. But let's consider the camera technology of today. I live in an aviation community in Houston, and little kids in my neighborhood have cameras on drones that send images to their virtual reality glasses. Okay, at that age, I had a Barbie doll and a coloring book, I'm just saying. And shown on this slide are photo shooting sunglasses called spectacles that I found online. And I'm sure a trip to the spy shop would reveal a lot of exciting camera options. Just for fun, let's imagine a future where we have safety glasses with built-in cameras that record video that can be sent to a phone or computer. And then imagine that those video files could be synced with the data files from the direct reading monitor using VEM software. Here's an interesting quote from that Spectacles on Snap Spectacles website. Cameras are going to be the eyes through which our computers see the world in which we can see each other's worlds. And that is definitely true on social media. We're all sharing each other's lives through the power of cameras and social media. Like it or not. Now let's focus on the next key component of the VEM system, the monitoring equipment. Of course, the direct reading instrument must have a data recorder to automatically record the concentration measurements or other data points. The monitor must produce a digital or analog output. The analog output for most occupational hygiene instruments is simply a voltage that is proportional to concentration. The instrument also must be able to respond to changes in concentration in a shorter time than the events being studied. And this is to avoid, a distortion of the concentration profile. This timing is critical. My young techie coworker has informed me that there are some technical issues, technical hurdles, if you will, that you may face using VEM. Like with the camera, manufacturers of direct reading instruments may block the data output for proprietary reasons. That's simply because they want users to buy their software for data analysis. Also, the data output from the instrument may be in a format that makes it difficult for the VEM software to make sense of it. And believe me, this techie stuff is something I learned from other people. This is not my thing. But for example, what I've been told, a column header or footer in a data spreadsheet can confuse the software. It's looking for a concentration level. And when it sees a header and footer, it doesn't know what to do with it. So to overcome these kinds of issues, VEM software developers may provide so-called plugins for specific instruments to allow them to communicate effectively with the software. And if you go to the NIOSH webpage for the EVADE 2.0, they offer some help with plugins for specific instruments. Now, in my opinion, NIOSH really has done a totally awesome job in reawakening the world to VEM. You know, this is a time in history where technology is moving forward at lightning speeds. So this is a good time to really link up to sensors and the computer technology. In February of this year, they released EVADE 2.0, and there's a number of updates on their webpage. Of particular note, NIOSH says that EVADE 2.0 allows the playback of any video stream against any logged data stream. It allows users also to take multiple data files from different types of instruments. So you could have a video with log data simultaneously from a dust monitor, a noise monitor, a gas monitor, and at the same time watch the video. Very nice. Now here you can see a screen capture from NIOSH EVADE. If you look at the graphical representation of the data on the bottom right, you can see that it allows users to zoom in specific segments, and what is really, really nice, there are these so-called bookmarks. What that means is, like, you can click on the peak of the graph, and then it automatically directs you to the video segment that show what the worker was doing that generated that peak. You know, nobody wants to sit and watch 8 hours of video. You know, if you're going to do that, you might as well just go into the work environment and watch it live. So this just allows you to just bookmark and just go right to that activity. Very, very nice. So let's now look at how VEM is being put to use for occupational hygiene and some other applications. Yes, the whole VEM started with dust in mines. Respirable dust in particular was the primary focus. And using this helmet cam, workers wear a small video recorder, as you can see on his hard hat, with a dust monitor in a backpack. That's how it all started. And at the end of the day, the video and the dust exposure data files are downloaded and merged with the software. That's where it began. In the YouTube video by Dr. McLaughlin, he shows an early NIOSH health hazard evaluation at a company that was experiencing high dust levels from the scooping task. And they called NIOSH in because they were getting ready to have to spend some serious money on a control system, on basically a new ventilation system, because what they had wasn't working. So after watching the dust levels over the workday using the VEM, the root cause of the high levels was determined, and a simple yet cost-effective control was developed. They simply cut the height of the drum from which they were scooping, and then cut it to half the height, and then used their existing slot exhaust system, and it worked. The exposure levels went down, all thanks to VEM. Of course, VEM is also a perfect tool to uncover the root cause of high noise exposures. Again, you're never sure what caused it. And now with the multi-channel features of VEM, you can simultaneously monitor dust, gas, vapors, and noise. Now, of course, that sounds good, except no worker's not going to want to wear 3 different monitors, right, and a video camera and go about their job. But, you know, if you want to do multiple instruments, you do have the option of area sampling, area monitoring. Now, in addition to occupational hygiene, Dr. McLaughlin told me of an application he knew of where people use VEM for community noise studies, right? So they had the noise meter and the video in a set location in the community to identify loud vehicles in excess of the noise ordinances. They basically, you know, videotaped the car and got the license plate. You know, it reminds me of how you can track down people who drive through the toll booth without paying, right? They can track down your license plate. Note, not that I've ever had any personal experience with that, but I've heard other people have done it. Now, VEM has been used to evaluate ergonomic concerns. I think Jim was involved in a project looking at luggage handlers in the airport and on a study of people who unpack and deliver case upon case of Coca-Cola and Pepsi and other soda pop. In this application, workers wore heart rate monitors in addition to the video equipment to monitor the cardiovascular load on the body with the work task. One of my hygiene buddies in the state of Michigan is doing a study right now in a brewery, and he is using a carbon dioxide monitor and a heart rate monitor along with the video equipment. So there's all kinds of cool things that you can do with this. Now, in addition to occupational hygiene, just for fun, I wanted to share with you also some process control applications. And this has been used in the pharmaceutical industry. You know, pharmaceuticals are expensive. They don't want to be losing that product. And so they have used VEM to identify work processes and activities that can lead to product loss in the production line. And I was thinking, when I heard about this, it reminded me of the same kind of thing with engineered nanomaterials. This stuff is expensive, and some of it is getting out of the production line. It's not just a health and safety issue. It's also, you know, an issue of concern to the company for financial reasons. They don't want to lose the product. Okay, next, again, I'm going to show you a couple videos from YouTube. Again, the quality might not be that good, but you can watch them again for a better view. This first case is very interesting because the worker was in a lab. She was exposed to high levels of benzene, according to the monitoring, but the fume hood where she was working was fine. So they couldn't figure out what the heck was going on. In the end, the video determined that the root cause of the exposure was that the worker kept touching her face with her gloved hands, and there was benzene on the glove. So again, you can just see when we were watching this video live in our office, we noted the girl actually touched her face 16 times in a very short period of time, and there's benzene all over those gloves. So they didn't have to get a new fume hood after all. Oh, this one, I love this next case study because it shows the value of the infrared technology. The IR camera was used in a VEM system to compare two different scavenging systems used to capture waste anesthetic gases. Okay, now check this out. Even if the video is bad, you can see, if you look at the scavenging system shown on the right, there is a large plume of gas showing that this scavenging system on the right was not working nearly as well as the beautiful scavenging system on the left, where you do not see the gaseous emissions. Very cool. So, in the end, I feel that the ultimate advantage to VEM is that seeing is believing. Traditional sampling tells us how much. VEM tells us why, where, how exposures are occurring. Our assumptions of the root cause can be wrong. Videos don't lie. No one can dispute the video and the data displayed. So it's a basis for communication of all interested parties and ongoing feedback. VEM makes good use of financial resources of the company. It enables you to make the right choice about controls, since you know the true root cause of the exposure. In so many of the studies you can see in the YouTube, there was a tendency to immediately jump to some sort of expensive engineering control, like a new ventilation system. But the VEM revealed that there was instead a simple cause and a simple fix. And again, it allows health and safety people and management to consider productivity issues along with the controls. So by just watching the task at hand and seeing if the workers will actually use the controls, see which one they like best. NIOSH has published a study in which they used the HAZDUS4 particulate monitor sold by SKC for a VEM study. The instrument not only provided real-time data to sync with the video files, but it also had an internal pump that could be used to collect a sample for lab analysis at the same time. And when I send all of the information to AirMet for people to get after this event, I will send a copy of this study as a PDF if you wish to have a look. Now, another potential VEM partner is a new HAZDUS4 that has just come out. It has been optimized for the measurement of silica at current occupational exposure levels. Silica is a very, very big deal right now in the U.S. as we have a brand new standard. This new HAZDUS4, which we call the SM4000, it's a light scattering device, so it sees all dust and not just silica, but it is factory calibrated using a test dust with a known amount of silica. The instrument is optimized to measure lower levels, and for convenience, it displays in micrograms per cubic meter and not milligrams per cubic meter. Finally, the instrument is fitted with SKC GS3 cyclone, so the instrument sensor only sees respirable dust. The reason it's used with the GS3 is that the manufacturer has an adapter to attach that device to the sensor. Like the standard HAZDUS4, this new SM4000 does the measurements in the breathing zone. A lot of the dust monitors on the market, like you wear them on the hip, but it's nowhere near the breathing zone. And the cyclone used in conjunction with the monitor allows for respirable dust measurements not only by the sensor, but for the filter sample to be analyzed by the lab if you wish to do that. Okay, Thank you very much. I hope I didn't keep you too long. Thank you very much for your interest in the webinar today. As I was telling Peter and Ivy as I was beginning this, I have learned most of this stuff myself within the last month or two. So I hope you've learned a lot of new things, and I'm sure many of you are online right now trying to buy your own spyglasses. I will keep you posted on any VEM developments from SKC moving forward. So thanks again to AirMet Scientific for hosting, and I will see you on the internet the next time.
Thanks everyone for attending today. I trust you found it useful and interesting. As you all know, AirMet represents the SKC product range in Australia, so if you'd like any further information on these products, please feel free to contact us. And finally, thanks Debbie for your time today. Always entertaining and a very informative and interesting presentation. So thank you very much.
Okay, thank you.